Hello, I'm Johan and this is
Barbara.
and we are about to present our entry for the Flashing Light Prize 2017, which is a negative differential resistance oscillator.
Yes.
So we just happen to have for another project on our breadboard negative differential resistance oscillator using a neon glow lamp, and this is also called Pearson-Anson oscillator, and this is exactly the type of neon glow lamp we're using. This is the circuit, and the way it operates is that it takes advantage of the voltage versus current characteristic of these glow lamps. So this one shows voltage versus current, and what happens is that when you go up, when you push more current through, you start with the dark discharge, then you push more current through, and at some point you reach breakdown and it starts lighting up. You see visible light, and then for a short range of current the voltage actually drops with current. So that is called negative differential resistance. So the regular resistance is just V over I, and that stays positive. We do obey all laws of thermodynamics here. So this is just another, this is not the real resistance, this is just differential resistance. And it does turn negative after breakdown, dark discharge after breakdown. You have a glow discharge in the subnormal regime, which is characterized by the negative differential resistance. When you go up in current, you level off, and the flat part of the curve is called the normal regime. And then when the voltage starts increasing with current, like we're used to in most other cases, that's called the abnormal regime. So you can make an oscillator based on this, but you have to stay in the subnormal regime, because otherwise there's no amplification. The way the circuit works is that the neon glow lamp, that's the electronic symbol for it, and the resistor form a voltage divider. And if you have a perturbation, these two power will be, DC power comes from the power supply, and some of the DC power is dissipated in the resistance, but there's if you're in the subnormal regime, there's another loss channel. So some of the DC power is actually converted to AC power, and that amplifies any perturbations. So that's what's driving this oscillator. And then you set with the RC, it sets a time constant. So that's the frequency it will oscillate at, approximately. So that's how it works. Since we had this working, we heard about Flashing Light Prize 2017, and we said, it should be really easy to use this circuit to flash an incandescent light bulb using the negative differential resistance oscillator. So if you see here, this is a transformer, so if you just short circuit the primary of the transformer, you just get back to exactly the standard oscillator. So our addition is to add a transformer and the incandescent bulb. And the problem is that, again, we have such a severe limitation on the current we can push through the circuit to stay in the subnormal regime so that it oscillates. If you try to push more current, it just stops oscillating, it's steady on. So that's the limitation on the current. And the incandescent bulb actually wants quite a bit of current to light up. So you need a transformer. So we are using a transformer, which is just a power transformer, and we think the turn ratio is about 30:1. So we take currents which are probably, for the neon glow lamp, they're like 10-20 microamps, and then we're increasing the currents and lowering the voltage across the incandescent bulb. It turned out that we just cannot get enough current through this guy, so we had to go to a bigger glow discharge, which we happen to have available.
Thankfully, despite our failures with the neon glow lamp, we have some better equipment, such as this glow discharge tube. it has some advantages over the neon glow lamp that allows us to achieve our goal. First of all, it has larger electrode plates. The larger area allows us to drive more current through the system, which was, as we said earlier, a problem with the neon glow lamp. Second of all, unlike the neon glow lamp, whose electrodes are fixed within the bulb, we have the ability to vary the distance of the electrode inside the vacuum tube. This allows us to create a greater separation between the electrodes and achieve a higher breakdown, which allows us to fix our breakdown voltage at a higher point, about 10 times as much as with the neon glow lamp. The larger area of the electrode plates allows us to drive about twice as much current. So that is
While remaining in the subnormal regime.
yes.
So we still have an oscillator at that current level.
So this equipment is a plasma glow discharge tube, and in order to create similar circumstances as the neon glow lamp, we need to be able to pump down the pressure with the vacuum pump. We have an air pressure monitor. We have our high voltage power source, about 1.5 kilovolts. Both of those systems are hooked up to the tube, which we can set up with our equipment, which includes our lovely transformer with our primary and secondary sides, 30 turns to 1. We have our 1 microfarad capacitor, which is rated for 1500 volts, which is important because we are working with very high voltage. This is the first of 2 capacitors in series.
2 resistors.
2 resistors in series. The second is over here. These together are about 1 mega ohm worth of resistance, and that is
So
closes the circuit.
the RC time constant should be about a second, which is what we're aiming for.
And the reason why we did this intro without any of the equipment on is the vacuum pump is very loud and does not allow you to hear clearly. This is the tiny bulb.
This is the tiniest bulb we could find, and it's actually one of the other entries in the contest. So thank you who made us aware of this. So this was, in terms of power requirements, this only needs, it's rated for 1.5 volts, 15 milliamps. And we're not going to get to 15 milliamps, we're going to get to a few milliamps here with 30 turns. And I'm no affiliation with the guy selling these. And I actually found that you could also buy them from China. This is a bag of 50 I bought for 20 bucks, which seems to be exactly the same. So you can get them for 6 times less if you're a bit patient. So no endorsement, but they're working for us, and it's the smallest wattage bulb we could find, and it does work for us. So all right, we should turn off some lights,
Yes,
and
we'll pump down the tube.
we will stop talking because the vacuum pump is really loud, so they won't hear it anyway.
Yes. We'll crank up the voltage and we'll show you our light blinking.